Hi, Suprit. Suprit. Arvo. Hi, Suprit. Bro, you can call me bro. Not sir. Ma'am will join. Yeah, are you currently working or what?
Can you hear me?
Yes, yes, I can. Are you currently
Okay.
working or you're a student?
Yes, but in different field,
Which field?
related to trading, stock market
Okay,
trading.
okay, okay. Got it. Yeah, I think ma'am joined. Hi, Deepika.
Hey guys, good evening. Hope you all doing great. So, what did we do in the last class? So we discussed about a logistic regression theory. We understood what is logistic, why it's called as a regression. I showed you the proof as well, right? And also we discussed about what are the metrics used to evaluate a logistic. Not in detail, just we got to know like which metrics we use. So today we'll start building a project related to classification. First thing, I want you people to download this data, open a new collab notebook. So once I show you the model building, I'll explain the metrics so that you'll understand. Otherwise, you'll forget now. Okay. So copy this data. I mean, just download it and open a new collab notebook and just upload this data into a collab. Let me know once you are done with downloading. Is it done? Done. Let me share my collab. You know, like how to start any project. Can you hear me? Am I audible?
Yes, you are audible. Are
Yes.
you sharing the
Okay.
screen?
Yeah, I'm sharing just a minute. It was showing for me like you lost a connection. I hope I'm that. If in case something happens, just message me, okay? I'll look into our WhatsApp. Hope you can see my screen now.
Yes, we can.
Okay. You do one thing. Take this notebook, create a copy because I have already added title, objective, as well as a problem statement. You know how to create a copy. Go to file and just click on save a copy in a drive. Once you create a copy, just upload that data, whatever you have downloaded. I'll add data set as well in this. Hard.csv whereas okay. Or you can just copy paste to your data, I mean to your Google Colab. Yeah. So how to do a regression project? So whatever regression data, continuous data you take up, the same approach you're gonna use and you'll be building a model. Yes,
One
yes, go
small
ahead.
doubt. Are you
Mm.
sharing this collab link?
Yes, I have shared it. Oh sorry, Alan. Wait. Yeah. Share.
Yeah, thanks. Yeah, thanks.
Shubhrit, your questions in logistic, yeah, all the pre-processing will be same. Instead of log transformation, we use a sigmoid. Sorry, we use a balancing. Okay, and different evaluation metrics will be used. And underfitting, overfitting applicable for all the models. Okay,
Okay, ma'am.
then uploading data. So understanding two projects is like more than enough for you to build different projects. So once I finish this logistic probably this week, I'll give you a list of projects. You can select whichever you want and you can try doing them. Okay. So keep ready with your implementation of a models, evaluating and all. Deployment also once I finish your ML. Yeah. So first thing, the project statement is, I mean, title is heart attack risk classification. It's related to medical data. Similarly, you can try with customer churn or a credit card fraud detection, something like that. So problem statement, goal is to develop a classification model that basically predicts the likelihood of or the what is the probability of heart attack based on various factors such as patient health indicators. So data set has a patient's demographic details such as medical history, diagnostic measures. So here the primary objective is to classify patients into two categories. What is the likelihood of experiencing an heart attack? That would be one. High risk of heart attack will be one, and those with less risk would be zero. Okay, yeah. And the objective, we're gonna build a machine learning model that to a classification model, which can help us in predicting the likelihood of heart attack. One always stands for higher risk of heart attack, and zero stands for low risk of heart attack. So the project also focused on identifying the most important factors that influence in heart attack risk, improving prediction accuracy using suitable pre-processing and machine learning algorithms, assisting healthcare professionals in early detection of risk in individual, and also reducing the chance of delayed diagnosis. So by predicting who is likely to get a heart attack, so they can undergo diagnosis bit early or else they can follow certain precautions in order to overcome that. Okay, so that risk can be reduced. Okay, so what next? So you know all these things. Let's go a little bit fast now. Import libraries, all this you know. If you want, you can type it or else you can just copy paste from my notebook. Okay, import all basic libraries like NumPy, Pandas, Matplotlib, and then seaborne as SMS. So these are the four basic libraries that we import whenever we do any project. Okay. So next important step, you have to load a data. So how to load data? So data equals pd dot read underscore. So clearly it's a CSV file, comma separated. So read underscore CSV, and then it should be hard dot CSV. Well, this is how you load your data set. See, this is the data set. So what should be the next step? Import all the libraries and just load the data set. Next important step is a domain analysis, because domain is new for us. We don't know much information related to this data, right? So you can clearly see that age, it's an age of a patient. Sex column, we have a male and female. A chest pain type. So we have a different types. You need to understand each category. Then resting BP, cholesterol, fasting BS, and then we have resting ECG. Again, normal or ST, maximum HR, heart rate, exercise angina, like is there a pain during exercise or something like that, old peak, ST slope, and heart disease. So, since this data is new for us, not every variable might be known to us, right? So, for that, we need to perform domain analysis, which basically helps us in understanding the data better. Okay, so I'll just give a heading as domain analysis or understanding variables. This helps us in proceeding further. Okay, so understanding variables. I'm just using ChatGPT for doing analysis. Just upload the data. It just gives you a complete analysis. Okay, like this. Can you copy from my notebook? I cannot paste. Please copy from my notebook. See, first column, it's an age. Age basically represents age of patient in years. So, medical importance of each column. Risk of heart attack usually depends on age, right? It generally increases with an age due to weakening cardiovascular health. Coming to our gender, we have male and female. The common, like expected thing or the most proven thing. So men are generally at higher risk of heart attack at an early age compared to a women. Okay, only when you do research like this, you get to know understanding of each variable. Otherwise, like how will you know? Getting chest pain type. So it's a type of chest pain experienced by the patient. So we have a different ones, okay? ATA in a sense it's a typical angina. NAP is non-anginal pain. ASY is like asymptomatic. TA is typical angina. So it's given the detailed definition as well here. So chest pain is one of the major indicator of heart attack problems. Different pain types indicates different severity level. Okay, so chest pain not strongly related to heart disease. Chest pain is not caused by heart issues. So no chest pain symptoms, but still have a heart disease, often considered like a high risk. You can see here. Atypical angina in the sense chest pain is not related to heart disease. Maybe due to gastric or normal pain. Non-anginal pain in the sense it's not caused by heart issues. Asymptomatic means no chest pain symptoms but still have a heart disease. It happens in many cases, no pain but still there can be an issue, often high risk. Typical angina, it's a classic heart related chest pain due to reduced blood flow to the heart. Getting so these two are like high risk. If it's an ADA pain or NAP pain, then it's not related to heart attack. Okay. And then we have a resting BP. So resting blood pressure. So usually blood pressure increases strain on heart as well as arteries, so which increases the heart attack risk. Okay. And then cholesterol. Even high cholesterol level will lead to plaque buildup in arteries, which increases cardiovascular risk. Similarly, we have a fasting blood sugar. So high fasting blood sugar may indicate a diabetes, usually more than 120. Considered like a diabetic, a major risk factor for heart disease. Okay, if it's lesser than those, then it will be like less risk. If it's more than 120, there is high risk of heart attacks. Resting ECG, so it measures electrical activity of the heart to detect abnormalities. Okay, so again, it has a different values like normal, ST, and LVH. So normal in the sense, normal result. No, nothing wrong with your heart. Okay. ST in the sense, it's an ST wave abnormality indicating possible heart stress or a damage. LVH in the sense, it's left ventricular hypertrophy. So that means enlargement of your heart muscle due to high blood pressure or a heart issues. So when it's an ST and LVH, you should be a little cautious. Okay. Max Headshot, it is a maximum heart rate achieved during exercise. So lower maximum heart rate during activity may indicate there is a risk or there is a problem in heart. Okay, and then we have exercise angina, that is exercise induced angina. Okay, it has a values like yes or no. So that means chest pain during a physical activity. So which may indicate reduced blood supply to the heart. Usually when people do exercise or treadmill run, sometimes people feel it like very much tired because there is no proper supply of the blood. Okay, getting that is a exercise angina. And then we have a old peak in the sense it's a ST depression induced by exercise relative to rest. So it indicates abnormal heart activity during exercise or a stress. Higher values will indicate severe heart disease. And then we have our ST slope. So what's the slope of the peak exercise ST segment? So we have three different things: up, flat, and a down. So important ECG related feature for detecting heart disease. One of them is ST slope. Up in the sense like upward slope, generally considered like a normal. If it's a flat, indicates that there is a heart disease. Downward slope in the sense, strong indicator of heart related abnormality, something wrong. And then hard disease column, we have two values, 0 and 1. 1 stands for high risk of heart attack, 0 stands for less risk of heart attack. This is how you do the domain analysis to understand what is available in a data. See, by doing this, you understood a lot of things. Yes, no. Without this, if you are doing directly, like, basic checks, cleaning, handling missing values, outliers, encoding, scaling, you do everything, model building, evaluating. But if you don't know what is up, what is flat, what is down, right, it doesn't make sense. First, you should understand the data. Only then you can proceed further. Got it? So nowadays it's very simple. Just upload your data to any AI tool. It gives you detailed explanation of each variable. It's so simple. It's not just pasting in a book. It should be like you should understand like what is happening in our data set. Okay. Yeah. So this is done. Next important thing. It's a very detailed information we got in this. So basic checks. You know what all basic checks we need to perform? Let's perform one by one. First one, data.shape gives you number of rows and columns. Print first 5 rows using head. Print last 5 rows using tail. And then data.info. Data.dtypes. And then print all the columns. And then print numerical columns. I'm not giving any explanations because it's already known to you. I don't want to repeat. Numerical means it's integer 64, comma float 64. Similarly, if you want a categorical column, the column which has a categories. So it should be an object. Okay. What next? We have to perform a describe. Yeah. Data.describe and data.describe for a categorical data. That is, you can just say include equals object. And then finally, you can print unique values and also you can print value counts. For that, we'll be using a for loop. For x in categorical columns, print, I use some format x, and then we call data of x dot unit, and I give one empty space. Same way for value counts, we just use for x in categorical columns, print x, comma, data of x dot value counts. Done. So much you have to do as a part of your basic tricks. Understand two projects, whatever I teach, you people do two projects. And understand all the logic, whatever I teach related to an algorithm, you are ready with a machine learning. They cannot ask anything apart from that. Whatever project you do, you should know how to explain each and everything that you do in a project. Okay. Whatever code you write, I don't say remember the code, but you should be able to explain what's happening. Okay, at least that knowledge you should have it. Like that again, do here two projects, one clustering, three, one deep learning related to images, four, one NLP, five, one generative AI, six. Total six projects. You can do one automation in it and eight. So almost like eight to ten projects in which you select the best ones, best four or five for your resume. Remaining put it in a GitHub. Or else if you want, you can do more projects as well. Okay. Yeah. Then till here, we'll run one by one. So number of rows and columns. So we have 9, 18 rows and 12 columns. If you understand properly, it's so easy. Done. Data.head gives you the first 5 rows. Okay. Tail gives you the last 5 rows. Info tells you about the non-null counts. I guess no missing values in this. Great. So data type. Okay, we have all three different types. Print all columns. Numerical columns. Cross check if anywhere the data type is wrong. Okay, we have all numerical values itself. Great. We'll go with categorical column. Even here, all text data categories. And describe. What we check in describe, is there any constant column in our data? Are there any constant columns in our data? If there were a constant column, your standard deviation would have been 0. We don't have constant columns, right? Okay, and also look for our minimum values. Can resting BP be 0? Can cholesterol of a patient be 0? Can fasting blood sugar be 0? I said to look for two things. One is minimum, another one is a standard deviation. So we need to fix here, right? Resting BP, cholesterol, and fasting BS. So these columns cannot have their minimum value as a 0. How come someone's cholesterol be 0? How come someone's BP be 0? There are no constant columns. That's the first observation we notice from this. The second thing is values cannot be 0 for these columns. It doesn't make sense, right? Values cannot be 0 for these columns. If someone's BP is 0, like what do you mean by that? So that means there are some incorrect data in your, incorrect values in your data which needs to be corrected. Okay, there are some incorrect 0 entries which needs to be corrected. Got it? Understood? Every data, every problem statement you try to solve, you will find out different things. Okay. So in this case, 0 is basically considered as a invalid ones. If you want to see like how many such invalid values are there, you can just filter data and you can check out. We'll try checking. Check for count of 0 in these columns. I'm just using normal filter data concept. So resting BP, sorry, resting BP equal to 0. So you can also call, you need to find sum of it. Let's call this dot sum. Let me put this within a bracket, dot sum. There's only one value 0 in our resting BP. And we'll check for, okay. Resting BP just 1, cholesterol we have almost 172, and fasting BS we have 704. Now, important thing, can fasting BS be 0? What is fasting BS actually? Fasting blood sugar, yes or no? Right? If you go back and if you have understood the data, in a fasting BS, you have just two unique values. Fasting blood sugar, like yes or no. If there is a fasting blood sugar, it will be 1. If no, it will be 0. So I cannot consider fasting BS now. Understanding, is it making sense now? Okay, don't directly blindly answer it. So, or else if you want, you can also check first the unique values in each of them. So, anyhow, resting maybe cholesterol, they're all continuous values, but in a fasting BS, it's basically discrete. It has just 0 1, so don't consider that. Okay, that's the reason it's 704. Well, so only in our resting BP and a cholesterol we need to handle it. So we got to know that there are some zeros. So what do you do with that zero? So we have to check the distribution, and then based on a distribution, we'll try replacing it with either a mean or a median. Okay, we'll do that later. We'll just do this analysis. Let's continue. So here everything is okay. Find unique values. So you can see male, female, chest pain type, resting ECG, exercise angina, ST slope, and value counts. You can see, and you can add one extra space as well. Yeah. So this is all related to basic checks. Understood, you should be a little cautious when it comes to data types. There is a possibility that data type can be wrong. Second important thing, you should be a little cautious when you do the describe. Describe tells you, are there any constant columns? If yes, standard deviation will be 0. So in our case, no constant columns. Second thing, we check for what? Minimum values. We understand, can that column can have a minimum value as a 0? If no, then you have to fill it with either mean or a median based on distribution of a data. Okay? Any questions so far you can ask. If no questions, let's proceed. Guys, understood everything so far? We'll proceed. Okay, great. So this is related to basic checks. The next important step is we have to perform a data cleaning or data pre-processing. So in data pre-processing, what we do, first thing, let's check for duplicates. Okay, so data dot duplicated dot sum. So well, no duplicates in our data. There are no duplicates. Great. Then we'll check for missing values. So data dot is null dot sum. So clearly no missing values in our data. Reduced. Few steps has been reduced. So there are no missing values in data. But what did we notice previously? But in our resting BCG, resting BP and cholesterol, there are zero values. Resting BP and cholesterol has few values has zero. So we need to replace them with a mean or a median based on distribution. So for that, first let's check the distribution. Okay, incorrect data, make sure you correct it under a data pre-processing only. I'll just use a subplot concept. Figure comma axis is equal to so BLT dot subplots 1 comma 2 figure size equals 5 comma 2 and then SNS dot we'll use histogram is plot and second one we'll just use a cholesterol. So it should be 1 and there should be subplots. Yeah, and let's use tight layout. And then we'll also give our KD equals to okay. So what do you say about it? Is it normal or skewed? If there is a doubt, just go and check the skewness. Okay. If you couldn't interpret what's graph, don't worry. Just go and check the skewness and then make a decision. So you can see even in a graph it shows like a zero. So cholesterol cannot be zero. It doesn't make sense, right? If someone's cholesterol is a zero. And also resting BP can also be not zero. So for x in A, I'm just calling x comma data of x dot skew. All these codes like comes with practice. Well, one is 0.17, another one is a 0 point minus 0.6. So one is greater than zero point 0.5, another one is less than 0.5. So sorry, yeah. So what do you say about this? Normal or skewed? What do you conclude? Forgetting everything. Resting BP greater than zero point 0.5, so it's right skewed. And then your cholesterol less than minus zero point 0.5, so it should be left skewed. Anything between minus zero point 0.5 to plus zero point 0.5, we call it like a normal. So clearly both are skewed. Will replace zero sim cholesterol and resting BP with median value. Okay. So we'll replace. How do you replace it?
Replacing by median.
We'll use a dot replace function. Okay, so good. So data of, I'll just call a column resting BP first, which is equal to, so I'll call the column again dot replace, what we have to replace 0, right? 0 with median value. So what you have to replace 0, comma, by what? It should be with a median value like this. Okay, done. Same thing, do it for a cholesterol. Same thing, do it for a cholesterol. In the place of resting BP, you just need to add a cholesterol. Code understood, right? I'm calling the cholesterol column. Even for doing different projects also, you can keep these projects open. You can take a code reference and you can change the column names accordingly. So cholesterol. Initially you feel it like, okay, like how do I remember? But by doing, practicing, you will get it. So done. If you want to cross verify whether it's replaced or not, you can check describe or else you can just use this as well. You can cross verify with data.describe as well. So minimum may not be zero. Yeah, it's not zero. Fasting BS can be zero because it is like S or no concept. It has just two values, 0, 1. That's the reason fasting BS can be zero, but not resting BP and a cholesterol. Understood this concept. We didn't see this situation in our previous data set. But usually it happens. Sometimes, as I said, if it's a constant column, you have to drop it. If it's a minimum values are zero, if that column should not take a minimum value as a zero, obviously you have to replace with either mean or a median based on a distribution. It's applicable for all the data sets. Okay, all good so far? Okay, next one is EDA. All done. Exploratory data analysis. Will you do exploratory data analysis or do you want me to show? Will you try? Can you finish by next class?
Okay.
Okay. I'm skipping this. You people do it. Take 1 or 2 days, and you can share with me. Then I'll update in my notebook. You need to plot a graphs as well as you have to write an insights. So univariate, bivariate, and multivariate. You know the different graphs that comes under univariate, right? histogram for numerical, count for categories. If you want, you can use pie chart as well, and you can also use a box plot. Okay, when it comes to bivariate, we don't have line chart as of now, but I'll mention it. Scatter, bar chart. Okay, multivariate, you can try a plot and heat map. Okay, try doing univariate, bivariate, and a multivariate analysis. Use the concept of hue to understand things better. You can also use a subplot concept and you can plot them together as well, your wish. You give a try. After you try, I'll show it. You can use subplots as well. First, check distribution of all numerical columns. Check are there any outliers. I'll give questions as well. Check distribution of all numerical columns. Use subplots or do it individually, your wish. And you have to write the insights as well. Check are there outliers in all the numerical columns. And then check count of all categories in categorical column. If you want more graphs, you can do it individually. Okay, like this. Then you can find relationship between cholesterol BP, and then you can use a hue like how things changes with respect to a heart disease. Okay, different chest pain type, cholesterol, how they're related using bar chart with hue. You can try. Give a try. Try for EDA. Okay, yeah. This is done. What next? Feature engineering. In feature engineering, what should be the first step? We need to handle outliers. Right. Handling outliers is the first step. And then you have to perform an encoding. Once you do the encoding, you have to perform a scaling, node transformation. Once scaling is done, you have to perform feature selection. Okay, using heat map. And then finally split your data. Data for X and Y. And then split data for training and testing. And then after we split data, we do the balancing. Check whether data is balanced or not. This is extra step in a classification. Okay. Check whether data is balanced or not. I'll explain what is balancing data, what are the different techniques we have. And then finally we have a model building. We'll be using logistic and then finally evaluate the model. So like this, now you keep on implementing different modules and you compare and you select the best one. Okay, that's it. It's simple process only. First, we'll check handling outliers. So for that, we just need to go with the numerical columns. Okay. So tell me which all columns I have to consider in order to handle outliers. So I have to check in age because age was continuous column. I have to check for resting BP. I have to check for cholesterol. Fasting BS has values like 0, 1, so no need to check. Max HR, yeah, it's in heart rate. You can check. Old peak doesn't have much variation, but still you can check. And hard disk is not required because it has a value 0, 1. Understanding why I'm not taking fasting BS under hard disks? Fasting BS as values like whether fasting sugar, blood sugar exists or not. Okay, hard disks as a values like 0, 1. Hard disks as a values like 0 and 1. Okay, yeah, try plotting box plot for this. Plot a box plot just to check like which columns has got outliers. Use a subplot, it will be easy. So figure comma axis is equal to PLT dot subplots. So how many in one single row I want a 5 graphs, comma fixed size equals 5, 2. Okay. And then SNS dot we want a box, right? Yeah. Box plot data comma x equals, so take one by one, age comma axis equals axis of 0, comma kd equals 2. Yeah. Just change the column name and axis. One, two, three. Okay. Oh, sorry. We are using a box code. Why I'm using a KDE then? I'm sorry. AFD.type underscore layout. Okay, so you have outliers in resting BP, cholesterol, max HL, as well as in a old peak, right? So everything except age. Okay, you check a skewness or check the distribution first, and then check the skewness, and then we'll decide which method we have to use. Check the distribution, remove age. We don't want age here, so it should be 1 to 4. Change graph name instead of histogram to his plot. Okay, and this should be removed. Change the numbers to 0, 1, 2, 3. Yeah. If this is done, find skewness and then decide which method we have to use it. You do that. Find skewness, use a for loop, and try to find it. I'll be back in 2 minutes. Okay, just use a for loop. You guys done? Did you find the skewness?
Ma'am, one question.
Yes, Abhi.
Uh, in resting BP, skew value is 0.17, so is less than 0.5.
Okay.
So we have to replace with mean, na?
Yeah, if it is normal, you have to replace with a mean.
Hmm,
Minus 0.52 plus 0.5 is a normal range.
okay.
Okay. And also, you should be a little cautious of the percentage of outliers. It should be less than 5% to replace. If it's more than 5%, you're not supposed to replace. Okay. So let me use x command df of x dot skew. So zero point 0.6 greater than zero point 0.5. See, I'll just give criteria again. If skewness is within minus 0.52 plus 0.5, it's a normal. We go with mean. Okay. If skew is less than minus 0.5, it's a left skew. We go with a median. If skew value is more than 0.5, then it's a right skew. We have to go with a median. Clear now? Now decide for which one what we use. Resting BP greater than zero point 0.5. I can say it's right skew. When it's a right skew, which method we use? A cure or a 3 sigma rule? Use I cure. Okay. Next one, cholesterol again right skew. Use I cure. Then we have one more. Old peak is also like more than zero point 0.5. I cure. And then one more. So we have a max HR. It's minus 0.14. So what do you say about it? So where does minus 0.14 lie? Within minus 0.52 plus 0.5. So we have to use a 3 sigma rule for this. Okay, is it clear? Max HR distribution is normal. You know why it's normal? Range is within minus 0.52 plus 0.5 because it's minus 0.1. It will be after 0. 0 minus 0.1 minus 0.2 minus 0.3 minus 0.4 minus 0.5. Okay, so we use 3 sigma rule. Done. Now we have to, okay, all done now. Like we just need to check. We need to implement IQR method now. Lower limit, upper limit, values less than, values greater than. and finding the percentage. Then till here, we'll do it. We'll finish this. So tomorrow we'll do scaling encoding as well as implementing model and also balancing also. Yes, Supreet, any questions?
Ma'am, can you please go to that zero handling portion?
This or this,
Upside,
right?
no, zeros, where we have handled zeros.
Okay, zeros. Mm.
Here then resting BP is in 0.1798, so it will be normal, right?
Oh, yeah. Sorry.
Yes.
I thought it like 1 point. Sorry. Yeah, then it should be normal. Sorry, sorry.
Yes, yes.
Okay. So I thought it like 1 point. So be careful. It's a normal. This is minus zero point 0.6. It's a left skew only. It is after minus zero point 0.5. Yeah. So here, instead of median, replace with a mean. Usually, what happens now? It's okay for mean. If you replace median, it's okay. When it should be a median, if you replace with a mean, then it becomes a wrong. Median,
Yes, yes,
median,
got it.
median is like universal thing. It manages. Please change this. Change it to mean.
Got it.
I'll just give you a resting BP is normal because skewness is greater than, I'm sorry, within minus 0.52 plus 0.5. Understood. Anyways, yeah. Replaced, done. Okay. Okay. Anyhow, outliers are there. Nothing changed. Check once again. Resting BP. Okay. It's right skewed. Cholesterol, right skewed. Max HR, normal. Old peak is right skewed. Correct now? Okay. Thank you. Thanks for noticing. All right. So we'll implement an IQR. So first we'll find Q1, Q3, IQR, lower limit, upper limit. Anyhow, copy pasting. First we'll write for first one. So data of resting DP. So Q1 in the sense quantile of 0.25. Q3 is quantile of 0.75. IQR is Q3 minus Q1. Lower limit is Q1 minus 1.5 times IQR. Upper limit is Q3 plus 1.5 times IQR. Same thing you can use for cholesterol as well as for a old peak. Only the naming can be changed. When you understand a concept, you can copy paste and you can be little smarter. Old peak, old. Okay. Now let's filter values. For which are greater than upper limit and less than lower limit. So it's a data of resting BP less than lower limit. So we have only one. I'll take a same code greater than upper limit. So we have so many. Okay, we'll find percentage and then it will, and we'll get to know like do we need to replace or not. Conditions, length of data of first condition or second condition divided by length of data into 100. Okay, first condition is this, less than lower limit. Second condition is greater than upper limit. Okay, it's 2.9. So less than 5%. Let's replace with medium. Okay. Replace with medium. Do you know how to replace? So data.log, take this or condition and within a bracket write the column name, which is resting BP, and fill it with median value. Dot median. You can check the percentage, it shows like a 0. It shows like 0. Okay. Hope it's clear. Done. Same way do it for cholesterol. Okay, let's find greater than. Upper limit. We'll find the percentage. divided by length of data into 100. So we have like 4.4%. Again, you have to replace with medium. Same code in the place of resting BP, I'm just replacing with a cholesterol. Okay, done. Same way you can do it for old peak as well. So we'll find a length. So 1.7, again you have to replace. So let's try replacing. Okay. Alright, done. So all three we are using median because you know the reason. Distribution is skewed, right? Okay. So now max HR, it's a normal, so we have to use a 3 sigma rule. You have to find a mean value, you should find a standard deviation value, and then lower limit is going to be, so it's mean minus 3 times standard deviation value, and upper limit is going to be mean value plus 3 times standard deviation value. Okay, and you know how to find a mean, it's just data of your max HR dot mean and for standard deviation it is just ST. Well done. Now you just need to filter it. So less than lower limit, that is 1, and then we'll use greater than upper limit. Okay, nothing, there is only 1, but still you can find the length. So it's your first condition. less than lower limit and greater than upper limit. 0.1%. We need to fill with mean because it's 3 sigma rule concept. Okay. Instead of median, I'll be using a mean because the distribution is a normal. Okay, done. So we have successfully replaced. It's okay, just ignore the error. I mean, just a warning it is. Yeah, done. So this is how you handle outliers in a different columns. All good, understood. Next class we'll do encoding for categorical columns and we'll do scaling for all the numerical columns for selected ones. And then we'll do feature selection, selecting features, splitting, and also model building will do it. Okay. Any questions? All good? Everything clear for the day? Okay. My session will end in some time. So this is a notebook. Try EDA and also you can try for encoding as well. You can decide a logic like for which column, which method. You can see male, female should be given equal importance. Chest pain type, resting ECG, exercise angina, S no. So you can go with label encoder. For ST slope, resting ECG and a chest pain type, like you have to decide like which has a severity. So that should be given a high importance. Okay. So your model will understand that. So if normal is resting ECG normal means it should be given less importance because we are looking for the person who has high risk of heart attacks, right? So the importance should be given for the symptoms that are related to an heart attack risk.